Section 6.4, Percent Applications. When solving percent application problems, one way to solve them is to rewrite the question into an is-of statement. Let's consider this question. Tom got 9 out of 10 possible points on his quiz. What is his percent grade? Now you may know just by looking at that his percent grade, 9 out of 10, is 90%. But let's set this up into an is-of type question. What it's really saying is 9 is what percent of 10? What I've done is I've taken the question and I've written it into an is-of statement. Now I can use the idea of is over of equals percent over 100 to solve it. My 9 is my is of 10. So 10 is on the bottom. What percent? I don't know what percent. So I'm going to have an X on the top over the 100. And now I have my proportion. 9 out of 10 is equal to X out of 100. So I know in order to solve this, 9 times 100 is 900. 10 times something also has to equal 900. So I am going to be doing 900 divided by 10. Once again, since I'm dividing, remember the decimal point in 900 is after that second zero. If I'm dividing by 10, I'm just going to move the decimal point one spot over to the left. So my answer is just 90. So Tom got a 90%, as we said before, on that, but we did it using this is-of method. Here's another example of an application problem. State sales tax is 7%. If a phone is listed at $249, how much tax do you have to pay? In order to go through and do this, I'm going to rewrite this into an is-of statement. What it's really saying is, what is 7% of 249? $249, that is. Because I have to pay 7% of that 249. Now I'm going to go through and set up my proportion. Since the 7 is associated with the percent, it's 7 over 100. 249 is associated with the of. What is, I don't know what that is, so that's where my X is. And now I have my proportion. So I'm going to go through and I'm going to solve this. I'm going to have to go through and figure out, well, what is 249 times 7? Now, I'm not going to take the moment here to figure out and do the math here, but I will tell you that 249 times 7 is 1,743. So I know that 100 times x also has to give me 1,743. Now, remember, what I'm really doing is 1,743 divided by 100 in order to figure that out. There is an understood decimal point after the 3, and I have 2 zeros in 100. So I'm just going to move the decimal point 2 spots over to the left. So the answer to this would be $17.43. How much tax do I have to pay? I have to pay $17.43, which is 7% of $249. Here's the third example. A computer ran 60% of a scan in 120 seconds. How long should it take the computer to complete the entire scan? Take a moment, maybe turn this off, see if you can figure out how you could put that into an is-of statement, and then turn it back on again. This is telling you that the computer ran 60% of a scan in 120 seconds. So what it's saying is 120 is 60% of something. And you don't know what that something is. So I'm going to put of what. So what it's really saying is 120 is 60% of what? Now, you may not have come up with that exact same is of. Perhaps you said instead 60% of what is 120. But realize these are both saying exactly the same thing. And it doesn't matter which one of those two is of statements you use, your proportion is going to be the same. I have the 60 attached with the percent, so it's going to be 60 over 100. It says 120 is, or is 120. So I'm going to have 120 on the top of what, I don't know what my of is, that's my x. And now I'm going to go through and solve that. So as I go through and solve that, I know that 120 times 100, I can just do 12 times 1 is 12, and I need 3 zeros because there's 3 zeros, 1, 2, 3. So that's equal to 12,000. So I know 60 times x also has to equal 12,000. So if I go through and I do that math, 12,000 divided by 60, I'd be saying to myself, 60 goes into 120. How many times? It goes in there 2 times. 60 times 2 is 120. I'm going to subtract and bring down my 0. 60 goes into 0, 0 times. 60 times 0 is 0. Subtract, I get a 0. I bring down my last 0. 60 goes into 0, 0 times. So now I have a remainder of 0. So the answer to this is it's going to take the computer 200 seconds to complete the entire scan. Many students have told me that the hardest part of solving percent application problems isn't solving the proportion. It's coming up with the is of statement. If you are feeling that way, you are not alone. As with anything, it takes practice before you might begin to get comfortable with the idea. There are a couple of other ideas we still need to consider in this section, and one idea is that of percent increase or percent decrease. Consider the following problem. A store offers a saucepan on sale for $92. The original price of the saucepan is $115. What is the discount rate? Before figuring out the discount rate, we need to figure out the actual cost of the discount. Originally, it was $115. Now it's on sale for $92. Well, that means that you have a savings of $23. Now we're going to use that $23 to write our is of statement, because you are wondering what's the discount rate. 23 is what percent of 115? $23 is what percent of $115? This is the important part of this. You are always going to compare it to the original price. So I'm figuring out the actual discount, and I'm going to compare it to the original price. So my is of statement, 23 is what percent of 115? And now I'm going to go through and solve that. I don't know what my percentage is, so it's percent over 100. The 23 is my is, 115 is my of. So I know when I cross multiply, I'm going to get 2300. So I know that 115 times something also has to equal 2300. So now I'm going to go through and I'm going to do my division. I have 115 times something has to be 230. 115 goes into 230 how many times? Well, it goes in there twice. 115 times 2 is 230. I subtract, I get 0. I bring down the 0. 115 goes into 0 0 times. So my answer is 20. So there is a 20% discount. But Once again, I found the actual discount and then I compared it to the original price. Here's an example of percent increase. Enrollment in a school increased from 800 to 888 students from one year to the next. What was the rate of increase? Well, once again, the very first thing I need to do is I need to figure out the actual increase. And if it went up to 888 from 800, the actual increase was 88 students. So my is over of statement is 88 is what percent of, and remember, I'm always going to use the original. It started at 800. So my is over of statement, 88 is what percent of 800. When I go through and solve that, I don't know what the percentage is, so that's x over 100. My 88 is the is, 800 is the of. Now I have my proportion set up. In order to solve that, 88 times 100 is 8,800. So I know 800 times x has to equal 8,800 as well. So in order to figure out what my missing number is, I'm going to have to divide 8,800 divided by 800. I know that 800 goes into 880 one time. 800 times 1 gives me 800. I subtract, I get 80. I bring down my 0. 800 goes into 800 one time. I get 0 when I subtract, 0 for my remainder. So the answer to this is 11%. So the rate of increase was 11%. The last idea to consider in this section is that of simple interest. Simple interest is the amount of money you have to pay on a loan to a bank or another financial institution. So here's the problem. Find the interest you must pay if you borrow $2,000 for 1 year at 5% simple interest. So you have to pay 5% of that $2,000. So that is what I have for my is of statement. It is saying, what is 5% of 2,000? Because I have to pay 5% of $2,000. Here's my is of statement, and now I'm going to go through and solve. Since the 5 is associated with the percent, it's 5 over 100. 2,000 is my of. What is the is? That's what I don't know, and now I'm going to solve that proportion. So I know that 2,000 times 5 is equal to 10,000. So I know 100 times x also has to give me 10,000. So once again, I'm going to have 10,000 divided by 100. Rather than doing the long division, all I need to do is move my decimal point 2 spots over to the left because there are 2 zeros, 1, 2, which means my decimal point is going to go right there after that second 0. So I have to pay $100 in order to borrow that $2,000, which means at the end I'm going to have to pay back $2,100. 2,000 is the original amount of money that I borrowed, also known as the principal, and $100 is the interest. Solving percent application problems is something that takes a lot of practice. Please let me help you as you have questions. Thank you.